Hi everyone, this is lesson 4.1 in Algebra 2A, and yes, I am teaching 4.1 after 4.2, but that's okay. This lesson is focusing on different ways that we can measure angles on circles and measure our way around a circle, which, as you probably know, is a pretty big deal in trigonometry. So here are the three ways that we're going to be talking about angles and turns and things like that on a circle. And you're probably most familiar here with degrees. Okay, I feel like you're pretty confident working in the land of degrees. You know that radians exist, and you've talked about some exact values of radians on the unit circle. But just to remind you, radians are really just a measure of the fraction of the way around a unit circle. Okay, so all the way around the unit circle is 2 pi. All other radian measures are really just fractions of that 2 pi. Okay. And then revolutions, I think you're kind of innately familiar with revolutions. Revolutions are just, one full turn around the circle is one revolution. And that's a little more practical, a little less mathematical. Okay, so there's some practical applications to talking about revolutions. So instead of writing down definitions for these three things, I think what I would like to do is put all three of these things together and just make sure we understand how they relate to each other. So in the land of degrees, the full circle, or one full turn around the circle, is 360 degrees. In the land of radians, that's equivalent to 2 pi. And in the land of revolutions, we would just call that one revolution. Okay? These three things being equivalent to each other is really kind of the cornerstone of all this conversion stuff that we're going to be doing, because all we're going to do is set up proportions using these values here. Okay, so knowing these three things, and if you need to, you can label this is degrees, this is radians, this is revolutions, but everything we do is just going to be taking things and writing fractions out of 360, fractions out of 2 pi, fractions out of 1 revolution. Okay, so like for example, in this first one, if I'm talking about 7 pi over 3 in radians, and I'm wondering what is that equivalent to in the land of degrees, here's how I'm going to do it. I'm going to set up 7 pi over 3, and because 7 pi over 3 comes from the land of the radians, I'm going to put that out of 2 pi. And then I want to convert to degrees, so down here I'm going to put 360 degrees, because these two things are equivalent to each other. That's the idea. So if I know these two things are equivalent to each other, I can make these two things equivalent to each other, and this is where I'm going to put my x. This is what I want to know, is what is 7 pi over 3 equivalent to out of 360 degrees, or in the land of 360 degrees. So I'm going to cross multiply this thing, just like a proportion. This is going to turn out to look like this. 7 pi over 3 times 360 equals 2 pi times x. So all I did there was I multiplied here, and I multiplied here. Okay? First thing I would do here is see the fact that you have a pi on each side and cancel those pi's out. Really what I'm doing is dividing each side by pi. And so now I have 7 over 3 times 360 equals 2x. Well, I can do this calculation. I can do 7 over 3 times 360. Let's see. That's 7 times 120. I'm just trying to do this in my head. I'm going to fail at it, I think. So that's 840 degrees. Yep, I would have failed at that. And that's equal to 2x over on the other side. And then let's just divide by 2, and you end up with 420 degrees for your x value. Okay? And so this right here would be your answer. 7 pi over 3 is equivalent to 420 degrees. I think that relationship will make more sense once we learn the unit circle. And I mean, you've learned it before, but once we do it again, and you can see what 7 pi over 3 would look like on the unit circle, you can see that that would relate to 420 degrees. But this is it. This is your answer. Okay? So 420, that's all you have to know how to do. I do just want to point out, I'm going to try to stay consistent with this. I want to stick with these values just because I know these three things are easy for you to remember. But I should also point out that in the land of degrees and radians, we can simplify this a little bit. And we can say we know that 180 degrees is equal to just 1 pi. So down here, instead of using 2 pi and 360, I could have used pi and 180. And that would have made it so that I didn't have a 2 left floating over here at the end. It would have made it so that just as soon as I do this calculation, it spits out my answer of 420. So if you use this, this does make your life a little bit easier. It saves you a step. I think for the sake of just always being consistent and always doing it the same way, I'm going to try to stick with using these, but feel free to mess around with that. Okay, and I would bet as you go through this, some of you are going to come up with some other shortcuts that work for you too, and that's perfectly fine with me. I have plenty of shortcuts floating around in my head. I just try to teach it in a way that's consistent. Okay. Okay, so let's look at this one. This is 42 degrees to radians. Okay, trying to convert degrees to radians. So it's going to be similar to this. I'm going to say 42 out of 360 because I'm living in these are both degrees, right? And then I want to know what this would be in radians. So I'm going to say I know 360 is equivalent to 2 pi. And then this is the thing that I'm trying to find. There's my proportion. So when I cross multiply, I have 42 times 2 pi equals 360 times x. And so what I would do here, just to make this all in one step, I'm going to go ahead and divide by 360 and divide by 360. And then this piece right here is what I would put into my calculator. You can do that all at once. So 42 times 2 divided by 360. Okay. Now, I don't want to put an ugly decimal here. What I really want is what is that as a fraction, because you know with radians we usually write our answers as fractions. So I'm going to hit math and choose that first option for fraction and then hit enter. And I find out that that's 7 over 30. You'll notice that I did not put the pi into my calculator, and that's because I want an exact value here, meaning I want my answer in terms of pi. I don't want to be messing with the decimal equivalent of pi. So I would write this as 7 pi over 30 equals x. So this would be my radian measure, 7 pi over 30. So all I did was, really, I just took this fraction and simplified it. I used my calculator to do it, but I got the decimal for this, I turned it into a fraction, and then I stuck pi back in my answer. Now, you'll notice that down here it says give a decimal approximation to your answer from above. That means go ahead and give it to me with the pi decimal in there. Very rarely do we work with radians in that context. We hardly ever work with decimal versions of radians, but it can happen. So I'm going to just type into my calculator 7 pi divided by 30. And there's my decimal equivalent. And it didn't tell me a place to round to, so I'm going to go just 0.733. Okay, and that's equivalent to 7 pi over 30. Okay. All right, so next up we're going to look at revolutions. How many revolutions equal 7 pi over 2? Well, 7 pi over 2 is in radians, right? So I'm going to say 7 pi over 2 out of 2 pi. And I want to know what that's equivalent to in revolutions. Well, 2 pi is 1 revolution. And I want to know what would this be then? Okay, if 2 pi is 1 revolution, what is this thing? Okay, so again, kind of sticking with that same pattern, I'm going to go 7 pi over 2 times 1, which is easy, right, equals 2 pi times x. I've got a pi on each side, so I would get rid of those pi's. And so now what I have is 7 over 2 equals 2x. Let's divide this by 2. And so I know from looking at this that this is going to turn into 7 over 4. And again, I'm just trying to build up your mental math skills here. That if I take something that's being divided by 2 and divide it by 2 again, it's really going to get divided by 4. When you're talking about revolutions, it does typically make sense to use decimals. So instead of saying, I mean, if you wrote 7 over 4 down on your paper, that would be okay with me. I mean, I wouldn't mark that wrong for sure. But if you were to ask me how many times do I need to walk around this circle and I were to tell you 7/4, that would not make a whole lot of sense. But if I were to tell you 1.75 times or 1 3/4 times, that would make a little more sense. So I think with revolutions, decimals just make a little bit more sense here. And so this is what I would probably put down. Okay, that's 1 3/4 times around a circle would be 7 pi over 2. Okay, a couple more examples here. All right, negative 5 pi over 6 radians to revolutions. So I think that's similar to what I just did. Don't let the negative freak you out. Negative 5 pi over 6. And that's over 2 pi, because we're living in the land of the radians. I want to know how many revolutions that is, so I'm comparing it to 1 revolution. And so I'm going to say negative 5 pi over 6 times 1 equals 2 pi times x. Get rid of my pi's here. So I end up with negative 5 over 6 equals 2x. Divide by 2, and I really end up with negative 5/12, which is equivalent to, as a decimal, I think it's going to be ugly. Yeah, negative 0.416 repeating revolutions. Okay. All right, so if I were to go tell you to turn around the circle negative 5/12 of a time or negative 0.416 revolutions, I think either one of those is going to throw you for a loop, but it's the correct answer. Now, does it bother you that we've got a negative revolution here? It really shouldn't, and I'm okay with you just saying that your answer is a negative revolution. In the land of revolutions, positive revolutions mean you're going counterclockwise, so this is positive. Negative revolutions just means you're turning in this direction. And that's the same as when we get to talking about the unit circle, the way that negative angles work versus positive angles. Okay? All right, so look at example 5. And this question tends to throw people off, but you're going to want to really make sure you have this one written down because I do know it comes up on the homework assignment. It says convert 12 to degrees. And I think with everything you've done up until this point, a lot of you would look at that 12 and just assume it was already in degrees, that it was talking about 12 degrees. And I'm lazy about this. I have to warn you that I am not always good about following through with this. But mathematically, the rule is if it's not labeled as degrees, we assume that it's radians, okay? Even if it doesn't have a pi in it. So this 12 is really being given to us in radians. And so you may be asking yourself, like, well, what the heck is that? What is 12 radians? Because we're used to talking about radians in terms of pi. Do you remember that example we did back here where we gave this decimal equivalent of 0.733? That's in radians, and it's got the pi kind of incorporated into it. So what this means is I've got something times pi that would be equivalent to 12. And it's some crazy thing, but some crazy thing times pi would be equivalent to 12 or approximately equal to 12. And so this is a whole number radians that is not in terms of pi, okay? Just for some reference here, remember we said that on the circle, 1 full time around is equivalent to 2 pi. So we can say that's approximately equivalent to like 6.28-ish radians if we were talking in whole numbers and not in terms of pi. So 12 radians is going to be almost 2 full times around the circle. Okay, that's what I'm talking about when I say 12 radians. It's going to be almost twice around. Okay, so let's do the actual conversion because you can do the conversion without understanding any of that stuff here. If we know this is in the land of the radians, I'm going to set it as being over 2 pi. And then I want to convert to degrees, so I'm going to set this up out of 360. Okay? So cross multiply just like before. 12 times 360 equals x times 2 pi. This time I don't have pi's that are going to cancel out on either side, and that's okay. So when I go to divide in this next step, I'm going to divide by the 2 pi. Now, normally I would tell you not to actually type the pi into your calculator, right? Usually we would just put pi in our answer, but we want our answer to come out in degrees, right? And degrees don't have pi's in them. And so I'm okay with this thing just coming out as a decimal and us just rounding that answer to say it's this many degrees. Okay, so I am going to type this whole thing into my calculator, including the 2 pi. So, and you do have to be careful about how you do this. What am I doing here? 12 times 360 divided by, when you do the 2 pi, I know our brains think of that as like all one thing, but your calculator treats it as a multiplication. They treat it as 2 times pi. So you have to put it in parentheses on the bottom of that fraction there. Otherwise, your calculator is only going to divide by the 2 and not the whole 2 pi. And so I get this 687.5-ish. Okay, and so that's my number of degrees. If I'm looking for an answer in degrees, I'm okay with this coming out of the decimal and just rounding it. And if you think about it, in degrees, 2 full times around the circle is 720 degrees. It's 2 times 360. So 687 is going to be like 1 full time around and then almost all the way around again. And we said that 12 radians would be almost equal to 2 full times around the circle. So that makes sense to me, that answer. Okay, so if I give you just a number and it's not marked in degrees, you assume that it's radians. Okay, assume that it's radians unless it's marked specifically as being degrees. Normally our radians will have pi's in them, but not always. Okay, I think that's it for this lesson. That's what you really need to be able to do, is set up proportions, do some cross multiplying. A lot of it can be done in your calculator. I would avoid putting pi into your calculator except in these weird ones where you're given radians that don't have a pi in them. If your radians don't have a pi in them, then you're going to end up with a pi in your answer where normally it wouldn't be. And so then I would just go ahead and throw it into my calculator and make it a decimal in that case. Okay. That's it from me today. Good luck with your homework assignment, and I will see you in class.